Hello, and welcome to my new screencast series about demystifying the parts of Java that we don't typically cover in a high school computer science class. My name is David Bach, and I've spent the last 7 years volunteering as a teacher's assistant at Loudoun Valley High School in Loudoun County, Virginia. In Loudoun, we have 2 computer science courses at the high school level, an intro course and AP Computer Science A. Both are taught in preparation for the AP exam, but there's a lot of stuff about Java that we don't cover. And, that's understandable. Our curriculum is really about learning to program, learning computer science concepts, and passing the AP exam. And Java has a lot of features that have more to do with working as part of a larger team of developers. And by large, I mean like hundreds of thousands of lines of code and dozens of programmers large over the course of a decade. That stuff isn't computer science, that's software engineering, which is outside the scope of high school computer science classes. Most of the features that we'll talk about here are about communicating that design intent of larger projects where a group of programmers will need to collaborate, or they'll need to talk about solving problems that are related to the computer industry, not necessarily computer science. Things like usability, maintainability, all those kind of abilities that we talk about in software engineering. If you've ever wondered what that public static void main thing is about, well, I'm going to explain that to you. These videos are for you. If you've ever wondered why main takes an array of strings, we're going to look at that too. If you've ever run into code that uses the keyword this, or seen syntax involving angle brackets that you didn't quite recognize, or wondered how to package your code up as a jar file so you could give it to somebody else, well, these videos are for you. I'm recording these videos now because this subject came up at a recent Computer Science Teachers Association conference. It's not part of the curriculum, but many students ask questions about this stuff. With so many school systems teaching remotely at the start of the 2021 school year, I thought I could make a few videos that would help explain this stuff and help out a bunch of students, and also give some supplemental curriculum to teachers to help with their asynchronous classrooms. So if you find these videos useful, remember the YouTube drill, hit those like and subscribe buttons down below for me, okay? Now let's get to this. So the first subject I want to cover is about the big picture parts of Java itself. When we say Java, we're really talking about 3 things: the Java language itself, the Java class libraries, and the Java virtual machine. So let's do a just quick overview of what those 3 things are. And in this video series, I'm going to try to relate to each concept to which area of Java it falls into. So let's first talk about the Java language. The Java language is when we're actually sitting there typing out code, and we're concerned about keywords like package and import, and how we inherit from class, and we extend things, and what's private, what's public, where semicolons go, all this kind of syntax of the language kind of stuff. It's the basic stuff that makes Java different than Python, or Ruby, or C++. Then there's the Java class libraries. The Java class libraries are everything that comes baked into the language that you can do things with. And this rabbit hole goes deep. Just to show you how deep, let's look at the Java platform standard classes for the current version of Java, which is Java 13. On the left-hand side, you see all these package names. You've probably seen things like this before at the top where we say import something. Every one of these is a module with dozens of things inside of it. We have stuff here for doing crypto, stuff here for compiling Java itself, stuff here for reading XML, which is a file format, stuff here for SQL, which has to do with programming languages for databases. I'm just going to show you some stuff you might have already seen before in Java Base. In Java Base, there are dozens of packages. You've probably imported stuff from Java I/O if you've ever read any files, Java Lang for doing basic stuff in the language. Java Math contains stuff like defining pi, some helpers for doing tangent, cosine, sine, all that kind of stuff. And down here is Java Util, which you've probably seen. Notice there's also a lot of stuff for handling dates and times and time zones and all kinds of stuff. But let's tunnel into Java Util. In here, you've probably, if you've been in AP, you've probably played with lists, sets, and maps. Here they are defined: arrays, stuff for collections, dates again, stuff for formatting stuff, a Gregorian calendar. The Java rabbit hole goes deep. If we come over here and look at Java Lang, which is the basic stuff you use all the time, you see this is where we get booleans and doubles and floats and longs and all kinds of stuff about the Java language itself. These are all the class libraries that every Java program has available to it without having to do anything special. And back in 1996, this is one of the reasons why Java was so revolutionary. It used to be that language did not come with many libraries at all to do this kind of stuff. Believe it or not, when I started programming, languages didn't even agree on how strings were represented. And you could buy third-party packages that gave you all kinds of stuff to bootstrap a new project, but that stuff coming baked in as part of a standard set of libraries that you can use, Java was really one of the first to do that, and definitely one of the first that was designed to do that on the web. And then finally, there's the Java Virtual Machine. The Java Virtual Machine takes the language stuff that we write and all the class libraries and even jar files that other people can write for us or we can write to give to other people, and they're run on this virtual machine layer. This is hard to visualize, which is why I have a graphic here, but it makes it so all that compiled code, it doesn't care whether you're running on a Mac or Windows or on Linux or on an Android phone or even on operating systems that no longer exist or will come out in the future. The Java Virtual Machine abstracts all the details of the hardware away so that our code works anywhere. Well, that's it for now. Thanks for joining me in this first episode, and I hope to have other episodes published shortly. Stay tuned for more. Thank you.